Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve the thermal analysis of bellow expansion joint. So this is my sample bellow expansion joint. This is made up of a steel material. So the material properties are given here. In this case, we are going to do a thermal analysis. So now we'll see the boundary conditions. So inside it has a temperature of 400 Kelvin and outside there is a external convection is happening. External temperature is 293 Kelvin and heat transfer coefficient is 25 watt per meter Kelvin. Now we will solve this problem using Salome meca. So now I have opened Salome meca. In previous case we have used to do the structural analysis of bellow expansion joint. Now we will take the same geometry file to do the thermal analysis. Just go to File, Open. The same file I copied and pasted here. Now we will open this study one file. Go to the geometry. That is because we can reduce the time for creating the groups, because we have already created the groups. So these groups we have already created, not required. Now just go to the mesh. The only thing is we just want to create the external surface. So inner surface we just want to apply the temperature of 400 Kelvin. Here we are not created the external surface boundary conditions groups. For that we have to create the external surface boundary condition group. Just create a group. Now we are in the mesh model. Just move into the geometry model again. New entity, groups, create groups. Now here just go to the face group. Now select the surface, inner surface. Just hide the surfaces. Then just view it here. So insert surfaces you have added now. Now we can simply select these surfaces. This is the outside surface. Just add it here. Just name it as outside convection. Just apply and close. Now you can simply see it seems both the surfaces are getting selected, it seems. Yes. So now just go to edit group. Now all the surfaces are getting selected. Now we just want to remove the inner surface. For that, select the inner surface. Yes, see, this is the inner surface. Remove it. Just apply and close. Now you can see only the outside surface. This is inside surface. Yes. Here you can see this is inside surface and this one is the outside surface. So inside surface we just want to apply the temperature of 400 Kelvin and outside surface we just want to apply the convection boundary condition. Now we have created the groups. Now we'll take these groups into the mesh. Just go to the mesh. Here just create a group from geometry. Select this one. Just apply and close. The same mesh only we have taken. So this is also we have done. So this is the mesh we have created. So the element size for the mesh we will see edit mesh. I have used NetGen 1D, 2D, 3D algorithm with an NetGen 3D simple parameter. The element size I have given as 0.002. This is little coarse mesh only for study purpose I have taken. So now we'll move into the aster study to create the setup. Just go to the aster study. So this is asking for the location. Anyway, we are going to use the previous case. Just delete this case. Delete it. Just save as. Now we have deleted the previous case. Now we just want to create a new case for the thermal analysis. Select this current case. Right click here. We can use the assistant to select. So add a stage with the assistant. Thermal analysis. So just next. 3D. So conductivity is 45. Next. So here we can give the imposed temperature in for inner surface 400 Kelvin. There is no heat flux. No. There is no volumetric heat source. No. Just save this file. The one thing is we are not applied the convection boundary condition in the using this assistant setup. So we have to add after creating this setup. So just go to the picture. Just naming here thermal.rmed. Just finish it. Now we have created the setup, but it's not the complete setup because we are not applied the convection boundary condition. We just edit. So this is the load. Just go here. This one is the imposed temperature, that is we have applied. For the convection boundary condition, we have to switch on this exchange. Just add it here. So apply to the group of element outside. Just save OK. So external temperature and heat transfer coefficient. Just see here, the external temperature is 293 and heat transfer coefficient is 25. So this one is 25, external temperature is 293. Just say OK, just apply and OK. Now we have applied inside 400 Kelvin and outside convection boundary condition. Both the things we have applied here. So this is the solver. We need to modify the solver. And this one is the output file format saving setup. Now the thermal analysis setup is done. Now we can solve this case. Just go to the history view. Just click this plus button. Change into odd 5 seconds. Give some more memory. Just run this case. Just wait for a while, it will solve. If any error comes, it will show with a red color around. Then after seeing message file, we can identify the error. From that we just want to modify it. Now it is solved without any error. Here you can see this is coming with a tick mark, and in message file also you can view it. So at the bottom, diagnostic job is OK. So there is no simple warning only, it's coming. Now we can go for paraviews to do the post processing. Just go to the paraviews. Just right click and open it. Pictures, code aster. So select the result file format. This is the thermal.rmd file. Just apply it. Just go to the thermal. So this is our temperature profile of our model. So just see the model in the blue to red rainbow with 12. So this is the temperature profile for the thermal analysis. Now we can slice and clip. So it's better to clip here to view the inside to outside propagation. Just apply it. Just hide this plane also. Yes. So this is the pattern of This is the temperature pattern along the thickness of the bellow expansion joint. So here mesh is little coarse. Here you can see it. So this is the way temperature profile is happening in the bellow expansion joint. So thank you for watching my videos. Please subscribe my channel for more videos and click the bell button for continuous notification. Thank you.